So this is a 3-variable K-map. Let's say the variables are A, B and C. So this is A bar, this is A, B bar, C bar, B bar, C bar, B bar, C, B, C and B, C bar, like that. So K-maps are used to minimize from the truth table. So instead of using Boolean algebra, K-maps are used to get the minimized sum of product expression. Now there are some standard methods to how to minimize from K-maps. First of all, only ones are transferred in the K-map from the truth table. So if we have a truth table and I want to complete the table, but let's say there are a few ones in the output of the truth table, those ones are placed here. So this is 0 0 0 0 0 1 0 1 0 0 1 1 1 0 0 1 0 1 1 1 0 and 1 1 1, like that. So let's say 0 1 1 is a 1, so we will put the 1 there. Then let's say 1 0 1 is a 1, we will put the 1 there, like that. And once we have all the ones, we will make groups of ones. But when we will group the ones, the group size will be power of 2. So it can be 2 to the power 0, that means it is grouped by itself, or 2 to the power 1, that means a group of 2, or 2 square, that is a group of 4. And then there are at most 8 cells here in the 3-variable case. So 2 cube, that's 8. So there won't be any odd number of grouping, or like if it is not a power of 2, that cannot be grouped. So, and the groups will be like adjacent, so these two can be grouped, but there cannot be any diagonal groups. No, that is not possible. So groups will be only in this side, or horizontal, vertical, like that, and they are just rectangular shape. So that's there. And then when the group is formed, any group is formed, the group we should try to make the group as big as possible. So let's say I will draw again. So this one, let's say we have a 1 here, and like that. So we will instead of making these two groups, that won't give us minimized expression, we will make the group the bigger one. So that's just one group. So one group as big as possible, and we have to take all the ones in the K-map at least once, but we can have overlapping of groups. So if we had, let's say we had another one here, we will, instead of taking it by itself, we will try to make it as with another one. So this group we will try to make it as big as possible. So we can do at most 2 or 4. So there is no 4 adjacent because this one goes diagonal, so only we can do this one, adjacent cells. So the remaining group, the other group, will be this one, and we will get the expressions from this one. So for this particular case, the expression will be B bar, C bar, B bar, C here, B, C and B, C bar. So for this one, this big one, the expression will be, we will just look at this side and see what is not changing, what is common. So when we go this way vertically, we see that A is changing, that's not constant. And when we go this way, we see that C is also changing. What is not changing? That is B bar. So we will write B bar for this group. That will be the expression, thus product expression for this group. Similarly, when we look at this one, we will look on this side, and we see that A is not changing because that's A there. This is not a bar. So A is not changing. So we will write A first, and then we will look what is not changing in this direction. So when we look there, we see that B is changing because B is B bar here and this is B here. So when we move from this cell to this cell, B is changing, but what is not changing is C. This is C here, this is also C here. So for this small group, C is not changing. So the expression for this one will be B bar C. And this is our minimized SOP expression from the K-map. So we have transferred this is I didn't draw the truth table, I just arbitrarily filled up the cells here just to show an example. But what we get from this example, if we had a truth table and if there were 5 ones in this way, the expression, the minimized sum of product expression we would get from the K-map is this one. I will do some examples. I did before, but I will do some more later. So yeah, this is just the basic principle of forming. And so as we saw, there is a overlap here. That's fine. There is no problem overlapping, but we don't take any one just if we don't need it. Like this one, I draw a 1 there, but I am assuming that there is no 1 there. But if there was a 1 there too, what would happen is there would be a 1 here, and I had to group this one, but I wouldn't group it alone. So what I would do, this one would go with this one. So that's all. That's the biggest group I can get because this one is not adjacent because this is diagonal, this one. So the expression for that one, let's assume this one is also there. The expression would be, again I can see a bar is not changing, so that would give a bar if this one was also present in the K-map. So a bar, that's not changing, and here what is not changing is c bar. We can see c bar is the same because b is changing. B here it is b, here it is b bar, so no b term but c bar. So yeah, it's just like that.